different type of problem. Draw the duplex winding diagram. Okay. For a DC machine having 4 poles and 32 armature connectors. Please just concentrate on this problem. Fine. Shall we go for the solution? So I write number of poles abbreviated by this P equals to 4. Number of conductors, that is armature conductors, abbreviated by this Z is 32. You have pole pitch equals to Z by B. This is nothing but 32 by 4. This is 8. Therefore, average pitch is YB plus YF by 2 is nothing but this is equals to the pole pitch. So implies YB plus YF equals to 16 and YB minus YF equals to 2m, where m equals to 2 for duplex winding. Okay? Therefore, YB plus YB minus YF equals to 4. This is equation 2. Therefore, 2YB equals to 20 implies YB equals to 10. Fine? Therefore, YF equals to 6. Since YB and YF should be odd, okay? Should be odd. Therefore, YB equals to 9 and YF equals to 5. You can either take YB is 9 or 11 and YF can be considered as 5 or 7. If you consider this as 11, you consider this as 7. If you are going to consider this as 9, you will be considering this YF as 5. And here the difference is 4, not 2, as we have seen in the previous examples. And this is a duplex one. So here we have to write one sentence and write it here. There are 2 simplex winding in a duplex winding. Fine. So therefore we will be having two winding tables. So we have first winding table. I write both side by side. Fine. So this is your first winding table. What is YB equals to 9, YF equals to 5. Just tell me how to proceed. We start from conductor number 1. So this is the arrow mark. What I just want to show you is that we start from this conductor. So what is the back pitch? 9. And plus 9 is 10. 10 minus 5 is 5. 5 plus 9 is 14. 14 minus 5 is 9. 9 plus 9 is 18. 18 minus 5 is 13. 13 plus 9 is 22. 22 minus 5 is 17. 17 plus 9 is 26. 26 minus 5 is 21. 21 plus 9 is 30. 30 minus 5 is 25. Good. So this 25 plus 9 is 34, that is excess by 2. We don't have 34 number of armature conductors because the given number of conductors are 32. Excess by 2. So this is 34 minus 5 is 29. Good. This 29 plus 9 is 38. Good. So they are excess by 4. Excess by 4 or 6? 6. They are excess by 6 because 10 number of armature conductors. Yes. Excess by 6. So this 38 minus 5 is 23. Exactly 23. So excess by 1. So you now reach first conductor. You have started from this first conductor. You have reached the first conductor. So the tabular count is exactly correct. This is winding table number 1. We have two winding tables. One is starting from 1 and the second is starting from the third conductor, that is the third stop. This is winding table again. So here having two winding tables in a duplex winding. Okay, and have the same thing. So similarly, we are going to draw two times. This is y equals to 9, y equals to 5. The back pitch is 9, which you are going to add. I will take the initial conductor as 3. We have completed the first winding table with the first conductor as the first slot. We have completed the winding table since the given problem is of duplex winding. So this is 12. Good. 12 minus 5 is 7. Good. 7 plus 9 is 16. 16 minus 5 is 11. Very good. 11 plus 9 is 20. This 20 minus 5 is 15. 15 plus 9 is 24. 24 minus 5 is 19. 19 plus 9 is 28. 28 minus 5 is 23. And 23 plus 9 is good. 32. 32 minus 5 is 27. 27 plus 9 is 36. So 36, we don't have 36 number of armature conductors. We do have only 32 number of armature conductors. So it is excess by 4. I have written 4. This 36 minus 5 is 31. Good. 31 plus 9 is 40. So excess by 8. So this 40 minus 5 is 35 excess by 3. You have started from the conductor 3. You have reached the conductor 3. The meaning is that your winding table is exactly correct. Yes? Two winding tables. Winding table number 1 starting from the first conductor, you are ending at 1 itself. It shows that your winding table is 100% correct. And you are starting with the conductor number 3. You have come back or ended with the conductor number 3. That shows that this lap winding or the U1 duplex winding is exactly correct. Now we'll start the windings. How many number of poles are being given in the problem? 4 poles. So it is abbreviated over here. It is given here also 4 poles. Shall I draw 4 poles? So fine. Good. What is a pole pitch? What is the meaning of pole pitch? Number of conductors under each pole they are in. So we are going to draw. Okay, these are 8. Under each pole, 8 conductors. So I will name the pole faces. This is north pole, this is south, this is north, the adjacent again is south. I will name the slots. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. So the total number of poles, the total number of conductors are 32. So pole pitch is 8. Under each pole there are 8 conductors, 8 slots. 8 ones are 8. Again 8 here under the pole face south. If you consider this as north, the adjacent will be south. The very next adjacent will be again alternating north, again south. The total number of given poles are 4 poles. Pole pitch under each pole there are 8 conductors. So there are 8 slots. Okay. So therefore the next is 9, 16. 8 ones are 8. 8 plus 16. 8 is a 24. 8 to the 32. Shall we start? So referring the first winding table, we start from this conductor, slot number 1. So what is the span? 9, it goes for 10. Fine. Okay. From 10 it comes back to 5. Tell me, from 5 it goes to 14. Good. From 14? 9. Good. 9 to 18. Good, very good. 9 to 18. Just see the center. 9 to 18. Good. 18 to 30. Then 13 to 22. 13 to 20. We'll have 26. From 26 it comes back to 20. That is the back pitch.
21 to 30.
21 to 30. Good. 21 to 30. This is the back pitch and this is the front pitch. 30 comes back, it comes to 25. Okay? From 25 it goes to 2. It goes to both the sides. We'll have, this is from 25 goes to 2, and from 2 it comes back to 29. So this is comes from 2, 29. From 29 it goes for 6. Fine. From 29 it goes for 6. So okay. From 6 it comes back to, yes, 1. From 6 it comes back to 1. This is the first winding cable that we have completed. We have started from the first slot, that is the first conductor. We have arrived back to the first one, that is the lap winding. So this is exactly correct, the winding cable. According to the winding cable, whatever we have drawn, the winding diagram is exactly correct. Now we will go for this winding cable number 2. Okay. So we are starting from the slot or the conductor number. This is progressive lap itself. Unless and until he is not mentioning the retrogressive winding, you have to consider the given winding as progressive itself. Since it is a lap winding, it is progressive lap. So we start from conductor number 3. So what is the back pitch? 9. We are going to add the back pitch. So it goes for the 12th slot. So here it is the 12th slot. So it comes back to 7. Yes. From 7 it goes for 16. Good.
16 to 11.
Okay. 16 to
11.
11. Then
11 to 20.
11 to 20. Good. 20. 20 to
15. 20 to 15.
good. 20 to 15. From 15 it goes for
24.
good. So this is 24 from
19.
good. 24 to 19.
19 to 28.
19 to
28.
28. Good. Exactly. 19 to no. So this was from 6. It should have gone 29 to 6. Okay. So this is from 29 to 6. So this now it comes. If you just see here,
28.
28, 19 to
28.
20. Then
28 to 23.
28 to 20. We'll draw this a straight one. It looks more aromatic in nature and looks good for the winding. From 28 to 23, 23 to 32. It goes here 32. Then 32 to
27.
27.
27 to 36.
27 to 36, that is 4. Okay. I take that 4 here somewhere in between. This is 4. That is 27. It is in between 25 and what is that called as 29. 31. Okay. Fine. From 31 it goes for 8. So here you know this 8. Okay. 31 to 8. And from 8 back to 3. So this is 8. So this completes the duplex winding. Now for the, as you know that we have to draw the brush contacts. This is the commutator segment. So before that, let me tell you that we are going to draw the direction of induced EMF. So this is towards, so you will be drawing the direction of induced EMF like this. Okay. Similarly, it is from, so you will be taking or drawing the induced EMF coming towards the pole face, this. So alternatively for the adjacent poles, if this is coming downwards, this will be exactly opposite in direction. This is going upwards. So the next adjacent will be having the reverse direction. So this will be coming down. So now, after showing the direction of induced EMF, which is not mentioned, but you have to draw it. We have seen some of the fundamental problems where he has asked you to show the direction of induced EMF, show the position of brush or brushes, whatever, singular or plural, draw the equalizer rings, show the sequence diagram. But here, these two important concepts, that is the direction of induced EMF and the brush contacts, are more important rather than going for the sequence diagram and the equalizer rings. So now, with respect to this, we'll do a ring. We'll take these segments. This one. Okay. So this is okay. And this one. So you can see what you can see two commutator segments. The brush is going to have a contact with two commutator segments. You can see the direction of the induced EMF. So you can see the, what is this called as slot number 1 and slot number 6. That is the conductor number 1 and conductor number 6. The direction of induced EMF is coming towards the commutator segment that we are going to consider as positive. That is, we are going to benefit with this one. Something is going to come towards. So also you can see the slot number 3 and slot number 8. That is conductor number 3 and conductor number 8. The direction of induced EMF is as shown with the arrow mark. That with respect to the direction of induced EMF. So therefore these two constitute to the contact of the, what is this called as, with the brush on the commutator segments. So this commutator segment of 1 and 2 will be having a brush contact. In the previous we had seen only one commutator segment coming in the contact. So we will be shading this one. So since it is a duplex winding, again over here if you just see the conductor number 9 and conductor number 14, the direction of the induced EMF is going away. And also the conductor number 11 and 16, direction of the induced EMF is going away. We do consider this as negative. So the brush contact with the commutator segments 5 and 6 is negative. So we'll just shade it, hash it. And again in similar manner we have 9 and 10 this commutator segment to be positive, 13 and 14 to be negative with respect to the direction of induced EMF. Will interconnect this positive to positive, this negative and negative. We'll have one tapping and name it as positive since we are connecting the positive towards the positive, and here this contact as negative. So therefore, what is the speciality of this problem is that there are two commutator segments coming under each brush. So that is the speciality of this duplex winding. Fine? Speciality of this duplex winding. Since there wasn't any space over here, this is exactly right. With 16 commutator segments. 16 commutator segments. This commutator segment, as the space is too less, just show it here. This is the 16th one. So the total number of armature conductors are 32, and the total number of commutator segments is exactly half of the given conductors. Fine? So this is the winding diagram for the given problem. This is the duplex winding with 4 cores and 32 armature.